we have completed our fourth uh, earmark subject area on the basic probability, introduction to probability and normal distribution during the past 2 weeks. So today we are here to discuss on the fifth earmark subject area, that is on the confidence interval estimation using the theories that we have learned on the normal distribution. Uh, so with today's lecture, I think we have come to an important junction of our lecture series. We are almost close into the 50% mark of the earmark subject areas under the syllabus on the business mathematics and statistics. Um, if you look back on the areas that we have completed so far, that some of them has laid a foundation as to your uh, knowledge as well as the answering on the questioning on the examination paper as to how you should focus. I'll come to that question. Yeah. With that, some of the introduction sessions on the data presentation, then areas on tabulation, presenting, analysis. So that has laid some foundation. However, if you look at the examination paper, you might not see a complete 20 to 25 sort of a weightage being given on one of these areas. Rather, interestingly, if you look at the second 50% of your syllabus area, that is where you are being questioned mostly. Uh, Interestingly, probability that what we have covered under syllabus area 4 counts for ample number of questions in the exam paper, where you may see some questions in the compulsory questions, at least one or two, as well as you may see a complete question, or sometimes maybe 5 to 10 marks being scattered here and there. So as long as you can pick some of these areas on other related areas on portfolio theory, stuff like that, where you can at least score maybe 20 to 25% marks of the final paper just by focusing your theory on the probability. But when you look at the areas that we are covering under today, as well as the next, that is the sixth earmarked area on the hypothesis testing, in the recent past, we haven't seen much of weightage or attention being given. Certain papers, you may not see any questions being asked from these two areas. So what we are going to do is that from today, now since we have come to the syllabus area on the probability and the normal distribution, what we are studying today, the confidence interval estimation using the normal distribution, is nothing but mere an extension of the normal distribution. It's a very simple theory. So as long as you understand how to apply, and there's only one equation for your equation bucket to be kept in mind. As long as you can understand the theory behind that, it's very easy to tackle up any question that will be coming from that area. Unfortunately, we haven't seen much in the recent past. Okay, so the sixth earmarked area on the hypothesis testing, what we'll do is that we will shift it towards the end of our discussion series. That means from this point, we are 50% completed from the syllabus standpoint. Then we are coming to the important and more weights being given areas such as the regression, modeling, indices, those sort of areas. You may sometimes find a complete 20-mark question being tested at the examination. So we think it's very important for you to spend more time on those areas and learn those theories, so that both aspects that we have been discussing since inception, that is one on knowledge enhancement, and on the other hand, you completing the examination, both will be fulfilled if we focus that part. Then on the 10th earmarked area, we have an area called selected financial applications. So in that area, there are plenty of sub areas that we can discuss. However, when you look at the testing pattern of the examination, we have earmarked three most important areas, that is on the bond pricing, portfolio theory, and net present value and the project appraisal. So bond pricing, NPV, and portfolio theory will put you in a very advantageous position as long as you know your theories and equations for you to score plenty of 20-mark questions in the exam paper. So once we completed those five areas, I repeat, the regression, modeling, indices, and some of these applications, then as per the time plan that I have laid ahead, we will be left with a couple of more classes, maybe around 3 to 4 classes. So how we are going to utilize that time will be, we will come back to these areas on confidence interval estimation, and then we will discuss on the hypothesis testing on that time period, and we will look into some more different questions that has not been tested in your examination for you to enhance your knowledge. And if at all your examiner feels like, okay, I must test one of these areas in a one or maybe at least 2 marks MCQ question or a objective test question, you will be in a comfortable position to answer those questions. So I repeat, today's area, it's a very small area, actually an extension on the normal distribution. We will discuss the theory, and we won't see any questions being tested. Rather, we are carrying forward some questions on the probability and normal distribution. So the latter part of the session, we will try to iron out some of these questions and make ourselves very comfortable with the probability theory, so that you are in a much better position. There was one question as to whether we are seeing any changes in the syllabus this time. We, from the lecturer's point of view, I am not aware of any such change. And I mean, even if there's a change, I'm sure IBSL will be duly notifying you as to if we are getting more syllabus areas, or if you have been asked to reduce one of these syllabus areas. So far, we have not seen any such information. So in that circumstance, we can assume that comfortably these earmarked 11 subject areas are the ones that you can look into as far as within the mindset that you need to complete this examination once this time. Okay. So once we completed all the 10, and then we moved back to the hypothesis testing, that is the sixth one at the last. The next 2 to 3 weeks, what we'll be doing is that we'll be giving you a couple of mock exams. So you will have the real feel of the examination. You will find yourself doing mistakes, and we can discuss those mistakes prior to the examination. I mean, if time provides, we can at least do 2 or 3 mock examinations where you will be in a much comfortable position to sit for the final exam upon the finishing of the syllabus areas. Okay, so that's the plan that is been laid ahead. So I repeat, so with the today's session, we are demarcating the 50% point of our expected coverage. Then we are moving to the next 50% on the regression, modeling, indices, and the selected financial applications. Okay, that's the plan. I just wanted to take a few minutes and explain you where we have come so far and the plan for the next 50% of the syllabus. Okay, so with that introduction, let's move on to today's discussion onto the confidence interval estimation using the normal distribution that we have learned so far. Okay, if I take your memory a little bit back towards what we have discussed last week, we continued our discussion from the probability theory. We learned the very basics of probability up until certain rules: conditional probability, base equation, total probability, and then we continued our discussion into a normal distribution being converted to a standard normal distribution form, where we can apply the Z tables values that is being calculated by the statisticians previously comfortably to estimate the unknown territories in a given distribution. That means the most frequent one indicator that we can look into the standard normal distribution is nothing but the mean. You have a population, you don't have access to the entire population, rather you take a sample, right? We discussed some of the sampling techniques like strata, quota, convenient. So you may use one of these sampling techniques and take a small sample. But then the problem is that you don't know whether the sample that you have taken really represent the entire population. So in such circumstances, we learn that we can use a standard normal distribution, plot those data, and comfortably come to conclusions as to, okay, if my mean is at this point, that means with 1 or 2 standard deviations, maybe around 68%, maybe 95%, maybe 99% of my data will lie. So based on those conclusions, you can come up to certain decisions as to, say you're running a production company, a manufacturing line, or a marketing for that matter, or you may be doing a survey. In such circumstances, you may have to make decisions as to whether am I going to look into a certain range, am I going to omit certain values, am I going to only focus on up to 100, up to 117, kind of a nominal number. So that's why we learn the standard normal distribution as to the application part of the table also. We discussed few questions up until 19 March. We'll be continuing those questions today with the finishing of the today's discussion on the confidence interval estimation. Okay. These are the contents that we are covering. We will learn what confidence interval is first of all. Then we'll look into an example on how to calculate the confidence interval without discussing any theory. Uh, the the whole idea is to just to show you what sort of a answer that we are demarcating from the confidence interval estimation. Okay. Then we will look into the relationship between the standard normal distribution and how we take those intervals, how we use the Z value into this practical application on the confidence interval estimation, and some of the at least two examples on the confidence interval calculations for you to make yourselves feel comfortable. Okay. With that introduction, we will start the discussion today. So a confidence interval is a range of values that we are sure where the true value under consideration lies in. You have to underline the word true value here. That means now in our throughout examples, we discussed the population and the sample. So let's say we have 1,000 apple trees in a big apple farm. So can you go to all these 1,000 apple trees and collect some data? Let's say you want to measure the weight of an apple uh, during a particular season. You might not really in a good position to go to all these 1,000 trees, pluck all these apples and measure them. Rather, what you do is you select a small sample, maybe 50 trees. So when you use those 50 trees apples, you will come to certain conclusions. Let's say we want the weight of an apple. You will calculate the total weights, divide by the number of items. You will calculate the weight average. Then you will calculate the standard deviation. You can calculate different variance measures also for those apples. However, if you elaborate your interpretation from those 50 apple trees, what you're missing here is that you still haven't accessed all these 1,000 apple trees. So if you say by just using those average that you calculate from those 50 apple trees, could you say that my exact average or the exact mean should be 60 grams or 70 grams? You can't. Isn't that so? Why? Because the sample itself carries certain errors when you try to represent the population by the sample. So that is where the confidence interval comes into play. This is where nothing but we will define a small range, a symmetrical range between the mean that you calculate, and with a certain confidence level, we will say, okay, my true mean, now in this example, mean is the focus, okay? My true mean will lies in between the mean and plus or minus this kind of a range. But that statement I'm going to make with 90% confidence level, 95% confidence level, 99% confidence level. So that's the whole idea. Look at this example. We say we measure the heights of 40 randomly selected men and get a mean height as 175 centimeters. And the standard deviation is 20 centimeters. So how do you calculate these two? Just by taking all these individual values, taking the mean and taking the standard deviation. So upon calculation, now let's assume that you know how to calculate the confidence interval, and upon calculation, now you are going to make a statement. Rather, you are going to say, okay, the mean is 175 centimeters. Rather, with the usage of the confidence interval theory, you can say at 95% confidence interval, true mean, that means we have just taken the 40 randomly selected men, isn't that so? There may be thousands and thousands of men in this true population. So the true mean shall be 175 centimeters plus 6.2 centimeters or minus 6.2 centimeters. If you plot all these values in a small line, you will come across a diagram like this. You will have 175 as the mean, and the range plus 6.2 and minus 6.2 will nicely give you these two values at 168.8 to 181.2. Let's forget for a moment that uh, you don't know the calculation method. Rather, if your answer from the confidence interval calculation comes as 6.2 centimeters, this is what you're going to express. The whole purpose is to give a much fairer and a true value to your audience as to uh, where the true mean lies in. Can we only do this for mean? Why can't we do it for the median? We can. Can't we do it for the mode? Of course we can. What about interquartile range? Any measure up to now what we have discussed on the statistical indicators for a sample and a population, if you can plot it, if you can calculate it, you can do the same thing for the confidence interval estimation. You take that value and use that values number and the standard deviation, and then use the confidence interval estimation calculation and derive a conclusion saying with X% confidence level, I'm going to say my median will lie in between 100 plus or minus 5. So those kind of indicators will also be able to calculate using the same theory. However, in practice, in application aspect, you will see ample number of time the average or the mean being utilized in this jargon on the confidence interval estimation. One of the good example will be you will try to go to a store and buy an electric bulb. You will see on the face or the cardboard side of it, it will say the bulb will have an average lifetime of 10,000 hours, plus or minus maybe 500 hours. So that means the bulb will last for maybe 10,500 hours, and sometimes it will finish its estimated lifetime by 9,500 hours also. So that's the whole idea as to what we are going to do under this session. Okay. This is how we are going to calculate the confidence interval that I explained previously. Say, assume we have the number of observations. It could be the sample, it could be the population, doesn't really matter. So we have the number of observations as capital N with a mean of X bar and a standard deviation of capital S. Okay. First, what we have to do is we have to decide the confidence interval level. That means, for example, 95% or 99% or 97% as to our final conclusion and the expression. So if I take 95% and on the next time if I take 99%, will my value differ? Of course, it is going to differ. Why? Because I have changed the confidence interval level. Now we have to take the corresponding Z value first for this confidence interval that we are going to calculate. Now, for example, 95% confidence interval, let's say the Z value in focus will be 1.96. Don't worry, the next couple of slides we will discuss how this value will be coming. Okay, for the moment, let's say you have taken the Z value as 1.96. Now, this is the equation which you can use to express the confidence interval uh, in the final statement. Use that Z value above in the formula below to get the confidence interval. That means this X bar is nothing but the average. In our previous example, that is 175 centimeters. Okay. Plus or minus, now this Z is the value that we calculated for the confidence level of 95%. That is 1.96. 1.96 multiplied by, this shall be the standard deviation, and divide by the root or the square root of the number of items that is in the sample that we are considering. Now, if we go back to the previous, what we can see this, where we can see this value, this X bar is 175 centimeters. Number of items, capital N is 40. S, or the standard deviation, is 20. If you plot these values, 175 here plus Z 1.96, S will be 40 and divide by the root of 40 shall give you the answer of 6.2. So that's how you derive the value. Now all what is left in our discussion is to calculate this Z value, how we can calculate that. Okay, we'll come to that. So this particular part, after the X bar or after the average or the mean, this plus or minus Z into S standard deviation divided by the number of observations root. This particular part is called as the margin of error in this discussion under the confidence interval. Call this entire part as the margin of error. Finally, I want to tell you this important note, that is this Z value that we will be using in the upcoming couple of discussions. That really depends with the so-called factor which we name in statistics as the degree of freedom, or capital D simple F. Degree of freedom is something which is marginally beyond the estimated timing of our course to discuss. The simple idea is that if you have, let's say, somewhere around 30 or below observations, you will have a different set of tables such as student T distributions for you to get a more accurate value for this Z value. But if you use a sample size of maybe, let's say, 100 or 1000 or significantly large sample, you can use the previous Z table that we have learned in our previous probability discussions to calculate this 1.96 under certain confidence level. So the whole idea is that we have not seen any instances as to the change of degree of freedom being tested with multiple tables being given at your examination under this level. So I just want to highlight these two factors on the margin of error and this degree of freedom, just for your knowledge. Don't worry, it won't get tested extremely. Rather, the basic idea is enough for you to understand that Z that we are discussing can vary depending on the sample size. So degree of freedom, in mere layman statistics terms, this is nothing but how many number of items that is in a particular sample that is free for the movement. So when you see the sample is a very small size, maybe 5 elements or 17 elements, we say that that is merely not enough for us to divert into the Z table and calculate the values. Rather, there we have different tables to get a more accurate value for this Z. Okay. So with those steps, let's once again conclude our discussion. You will find your average here, plus or minus, multiplied by the Z value calculated by your tables into the standard deviation divided by the root of the number of elements. That is how we are going to calculate the confidence interval, what we have explained in this very first example. Okay, let's move on. Now, this confidence interval can be elaborated by the standard normal distribution, where the Z value that we discussed previously is nothing but the Z score that we learned to calculate in our previous discussions. For example, now when you say 95% confidence of that your particular true value will be between this particular range of plus or minus same value, plus or minus 6.2 centimeters in our previous example. What we are eventually doing is, if you could recall our discussion on the previous nature of this standard normal curve, we have learned that this curve is symmetric. The left side from negative infinity to 0 and the right hand side from 0 to positive infinity has the exact same bell curve. So what we have done is nothing but we have just calculated two values as to where the 95% area under the curve will cover our set of observations. If you look at 95% in this diagram, what you're omitting is nothing but 5%, isn't that so? So we have the 100% covering the entire bell curve. We have to take off 5%. And there, of course, we know that the curve is very symmetric. So eventually what we'll be doing is that we will be taking off 2.5% from the negative end, and again another 2.5% from the positive end. So if you take a moment and take one of your exam papers and scroll to the page where you have this Z table that we have given, you may find now at this particular plus side of our margin, what would be the value that there will be? That will be 2.5 plus 95, isn't that so? From negative infinity to this particular point, you have 2.5 of the 2.5% of the data. And from this point to this extreme positive point, you will have 95%. So that means this should be 97.5. Okay. So if you look into your tables and keep an eye on where you will see this 97.5% area under the curve is covered, you will find that in the second page under Z score 1.9 and on the columns 0.06. So 1.906 is could be calculated by the same Z table that is given to you. So there's nothing new here. And on the other side, if you want to calculate this 2.5%, again, you scroll down to the first page of it, the negative aspect of your table, the same place under negative 1.96. If you keep an eye on your table and see under negative 1.96, you will see 0.025%. That is where this 2.5% comes into play. So with this discussion, you're learning something important. That means if you could, calculate only one side of the table, the Z value, the exact opposite will be the symmetric opposite side in the negative side also. So if you just calculate 97.5% here and get 1.96, that is enough for you to judge that the negative 2.5% will carry the negative 1.96 Z value. So that is how this particular Z value that you applied in this particular place comes into play. So at 95% confidence interval, you say that, okay, my Z is going to range from negative 1.96 to plus 1.96. So still you can elaborate all this by the previous discussions that we have completed so far. Okay. Now, what if I ask you to, be creative and tell me the 90% of the data where it will be lying on? It's easy. All what you have to do is that you can assume the same. Okay, this should be 90%. That means we have to take out 10% from the 100%. That means 5% from the right hand side tail and the 5% from the left hand side tail. So from 0 to in that case 0 to 90, you will compute one Z value. The exact opposite would be the other side negative value. That way you can, from this particular 0 point, you can do up to any calculation, maybe 80%, maybe 96%, maybe even let's say 50%. That's also doable computation. It will always lie on this 0 mark overlapping, because why? Both 50% will be taken to left hand side and right hand side equally. So any value that you need to express for your confidence estimation, you can say, you can use the Z table and calculate comfortably. All what you have to do is that just calculate one end up until the positive and apply the same for the negative range. What I have elaborated here is the explanation from this straight line and these dots and these small bars. What I'm going to explain you is the elaboration of this 95% confidence interval. Okay, now let's switch back to the board and try to see what we are going to discuss here. Now, in our previous example of these apple trees having 1,000 apple trees, and you have access to only 95 trees, what you could eventually do is that you can calculate, you can plot these 50 apples in a nice curve like this and calculate the average. I hope the board is visible. We just try to use different one. So for these 50 apples, first, the first 50 apples, you can plot the data in a standard normal curve and calculate the average. Let's say average 1. And with the 95% confidence level, you can say this is my limit 1, limit 2. You can say 95% of my data lies on this range of L1 to L2. Again, you apply a different sampling technique now. You can say, okay, in the previous technique, I used the random sampling technique. Now I'm going to use the convenient or strata or quota kind of a technique. And you take another 50 apples. Okay. Again, you do another graph. You will find another average. This time I'm going to name it as D1. Again, you will express yourself with the 95% confidence interval saying that, okay, my range will be T1 to T2 in this time. So similarly, if you do this test for, let's say, 20 or 30 different times, you will be left with a much more correct average value. The A1 and the B1 is the focus here. Okay? You'll be left with a much more clear and a greater accurate average value for this particular data set. If you look back to that small diagram I have put here, on the right hand side, what you see is those, if you take the very first line and the dot, what I'm going to explain you is that that dot is nothing but the average on the first test that we conducted. And these two small bars will represent the 95% confidence interval. Okay. The second test, okay, it seems to be a lucky test because that the dot exactly going to pass this bar that I'm going to explain in a little while. And this is the limits of that particular test. The third one, fourth one, so on and so forth. So this each and every line in the small diagram, assume that it represents one of these tests. Maybe sample size maybe 40, 50, different sample size, different sampling techniques you can use to gather the data and plot them and conclude your 95% confidence interval judgment. Then this bar, this vertical bar is nothing but the true average. It can be the calculated true average from your population, provided you have the access, or it can be the simple average of all these lines, or weighted average, or any arithmetical average which is appropriate depending on the scenario, which will represent the true average or true mean. Now, if you carefully look at this diagram, students, you will see that there are a couple of blue lines here. What I'm going to explain you is that is the 5% you are missing in this particular estimation. If you look at that representation, you will see the very first line, okay, this particular blue line, you will see that the range doesn't even come to the true average. Even if you look at the second one also, you will see, okay, marginally the lower limit touches the true value, but still it is not representing. The third one also, even the range doesn't cover the true value. So assuming this line, this vertical line is the true mean, these 3 points are these 3 blue lines are the tests that you have missed in this particular instance, where you will not find the true mean or the true most accurate mean or the population mean, provided you could calculate this in those tests. So that is why with the confidence interval of 95%, even if you say that, okay, my in the very first example, we have said that 175 plus or minus 6.2 centimeters will be covering the true mean for this set of men at a 95% confidence level. But if you really calculate the true mean, maybe in 5% of times you will miss your estimate, where the true mean will not even come close in between the confidence interval that you're going to define. So that is why I just put this diagram for you to explain the 95% scenario where you're missing the 5%. If you put up the 99, scenario is the same thing. Maybe only one instance you may miss your true mean to be inside the range. Okay. So in practice, if you look at the Z values, so this 1.96 is a very popular value where, eventually when you do a couple of sums, you will keep that value in your mind. Now, if you look at this 80%, you have to omit 10% from the left tail, 10% from the top tail, and accordingly, this is where your Z value plus or minus 1.28, plus or minus 1.4495%. So similarly, by using the Z table, so some of these confidence interval levels that we can apply for the computations and sums and the exams is given in this table just for your information. Just remember the fact that depending on the sample size, this value that you're going to choose for the Z may not be really accurate if you're choosing a very small sample size. In practice, if you ask me, okay, will we be given a question to calculate these two intervals? I could say, any examiner with a sensible exact table being given at the back of the exam paper could ask you the same. However, due to the nature of testing, I mean, you have plenty of other areas to be tested also in this small number of hours. So there's a high probability that you will be given this value, say at 95% confidence interval, assume the Z value is 1.96. So in that case, you don't have to even go to the tables, rather take the value directly and apply it for your calculation, where x bar plus or minus Z into standard deviation divided by number of events into the root. Okay, so these values, I mean, one could use the table, or you will see this in the sum itself. Okay. Now let's see one of the examples that we can discuss here. There are many apples on a tree. One apple tree, many apples. You have chosen 46 apples randomly, and the mean weight is 86 grams. Standard deviation is 6.2 grams. That means if we quickly go back to our previous discussions, 68% of the weights should be around 86 gram plus 6.2 grams, or 86 grams minus 6.2 grams. Okay. Just a refresher. The question asks, what is the range of confidence interval at 95% level of confidence the true mean shall be? Okay. Now, similar to our previous discussion on that heights on centimeters, these are apples with grams. You have a mean and you have a standard deviation, and the question asks you at 95% confidence level for you to give you the range of this mean that is going to be. Now, the question itself has given take Z at 95% confidence interval as 1.96. So this is nothing but applying the missing pieces into the equation. So x bar is given 86 grams. Z you can take from the question 1.96, or if you really want to, you can use the tables and also calculate. Plus or minus, important, don't miss that. Standard deviation given 6.2 grams, and how many number of items in the sample? 46. So you have to take the root of 46. So this particular margin of error will give you 1.79 grams. According to how you're going to express yourself here is, you can say the statement as follows. At 95% confidence interval, the true mean shall be 86 gram plus or minus 1.79 grams. Okay. So this is merely one example you can calculate. The next one. Now here, I'm going to give you a raw set of data. We'll take a minute and try to calculate this. With this, I think today's discussion is over. That's all what we have to cover under this area, as to give you a brief introduction onto confidence interval and to learn the simple computation behind the confidence intervals. Okay. So what we have here is a set of raw data. Calculate the 95% confidence interval for the mean value of the following data set. And similarly, I'm asking for 95%. So the confidence interval value for the Z corresponding to 95%, you could take as 1.96, both plus or minus. Okay. So if you look at the raw form of this question, how many number of items that you can see here? You have 10, 12, 11. Let me, in the interest of time, let me just quickly take the answer itself. So number of items, let's say you have value here, then what you have to do is that you have to calculate the sample mean. Take the summation, divide by the number of items. And what is the standard deviation? Again, you have to do the computation, each value minus the standard, minus the average or the mean that you are calculating here, divide by the n, take the root. So this form also, you could be given a nice question for you to compute the values. So where we are heading now? In the previous questions, you have given the mean and the standard deviation. But in this question, you can be easily given the task to calculate the mean and the standard deviation also. Now, once you have those number of items, sample mean, and the standard deviation, again, what you can do is that, okay, now you know the sample mean, X bar covered, you know that. Z value, question has given it. However, if you wish to, you can calculate by hand also. What about the standard deviation? You have calculated here. You can use that value here. And number of items, just by computing the number of items given here. If you could take a minute, you can calculate this, but in the interest of time, I'll give you the answers also. You have 20 number of items in the sample. Sample mean should be approximately 14.9. Standard deviation, you will get a value of approximately 3.4. Okay. Use those values, and at 95% confidence interval, you have to calculate the margin of error and express your answer. Okay. So the mean 14.9 will be plotting here, plus or minus a standard error will be, this entire part, when you compute, you will get an approximate value of 1.49. Okay. How you are going to express yourself in this case? You can say for this data set, at 95% confidence interval, the true mean. Now assume that this is just a couple of data set extracted from a bigger sample. Okay. In that case, you can say the true mean for this particular data set shall lie in between 14.9, that is the sample mean, plus or minus 1.49, that is the margin of error that you have calculated here, at 95% confidence level. By using the other side of the English also, you can express at 95% of the confidence interval. The true mean for this sample, or rather the population, will lie in between 14.9 plus or minus 1.49. Okay. So try it at home, and we can discuss the answers at an upcoming session also. That's the whole glimpse of the theory that we have to discuss under the confidence interval estimation theory part. If I recap, what we have discussed so far is nothing but the introduction onto the confidence interval, get an understanding as to how you elaborate yourself with 95% or 99% or 80% kind of a confidence interval in the first place. Now, how do you calculate that confidence interval? There's a high probability that question itself will give you, or if not the case, you can use the tables and calculate. Also, we learn the fact that we assume in that case the population will be having, the sample will be having much more number of data points, so that you can use the standard normal distribution table itself. Rather, we discussed that if the sample size is very small, the value that you calculate for the Z will not be very accurate. In such circumstances, there will be a different set of theory set that we need to discuss. And few applications also. provided that you have been given to calculate the confidence interval, and by using the margin of error, you want to express yourself, saying that at this particular confidence level, the true value shall be plus or minus in between this range. This is how you calculate. So the only carry forward from this entire section would be nothing but this small equation, that is the mean plus or minus z value into standard deviation divided by the number of items to the root. That will give you the range when you want to express yourself by means of a certain confidence level. Okay. That's the whole summary of the today's discussion, and now we can continue. We have approximately 1 hour plus, so now we can continue the past paper questions that is coming from this both areas on area 5 and 4 that we have completed so far. Okay. Yeah. So with the completion of previous week's discussion on to probability and normal distribution, we have covered some questions. I think we did this 2019 September paper completely. This is a question on the probability computation. Then at question number 3, last part, we have seen the application on the confidence, not the confidence interval estimation, rather the interpretation of the Z by using the mean and the standard deviation, and calculate whether your particular interest of probability will exceeding or below or a particular range kind of a question tested in 2019 September. Third question, last part. Now this has come with the portfolio theory. So the other questions you can attempt when we complete the portfolio theory. This also we discussed, that was on the independent probability, where there are 3 contracts and we want to compute a combination of whether we are getting sector A, sector B, and sector C. This one also we computed, we discussed under 2019 March paper, where we discuss again the independent probability as to there are 5 production lines. The breakdown probability is given as 2%. So in such circumstances, we can assume that factories do not disturb the other factories in the production line. So comfortably we can denote an answer like this, 0.98 into the power of 5 for us to compute the probability that there will be no breakdowns. Okay. The same question, if they ask what is the probability that there will be a breakdown, the answer shall be C. Every factory has to go through a breakdown. That means 2% into 2% into 2% into 5 times. In that case, the answer shall be C. This also we discuss. It's on a you can apply the Bayes theorem here comfortably and see that the total output has been denoted into 2, A and B, 80% and 20%, and there is a defect portion. We call it the faulty here. So you can compute which has come from which production line or the total of it, kind of. I believe this is where we stopped at last week, 2019 March. We discussed question number 5 completely, if I'm not mistaken. So there we had a glimpse on the 20-mark question, how much time we need to spend on that. We understood that the different types of questions that is coming from a normal distribution point of view. So let's come to, from that point onwards, we'll try to drill down a couple of more papers down and cover more questions on the probability and normal distributions. Okay. So we are continuing today's session with 2019 March question number 6. And I am at the subpart number 3. Okay. Let's go to the question. A fast food company provides 2 types of mobile food vans for outdoor events. One company, 2 types of vans. Uh, One type of van sells ice cream and other type of van sells cup noodles. Okay, two production lines being channeled to these two vans, it seems. The daily profit of each type of van depends on weather pattern. Now this is the weather pattern. And on its past experience, the company predicts the following daily profits. Okay, so what they have done is in a table they have given for these two van types, depending on the rainy or the fairness of the weather, what would be the profit that each van is going to make. Let's just see whether those values in a rainy day, ice cream is going to make a negative profit of 5,000. That's sensible, right? In a rainy day, rarely you can see people go and try the ice creams. Rather, they will go for some hot meals. You can see the cup noodles, okay, seems to be making much more profits in a rainy day, 12,000 rupees. In a fair day, in contrast, people will go to ice cream. That's why this profit seems to be much higher, 15,000. In contrast to the cup noodles making an average profit of just 1,000 rupees. The first question, company plans to attend to an outdoor event in 2 days' time, where there's a 60% chance of rain and 40% chance of a sunny weather. Okay. Now for this unknown variable on weather pattern, now somebody has forecasted and tell this company there's a 60% chance that there will be rain. So the opposite will be there will be no rain. The company needs to decide which van should the company take to this event, and we have to justify our answer also. Okay, go back to the board and we'll try to have the discussion. Now the question is clear. We don't have the choice of sending both vans. So we need to pick one van depending on the weather forecasted pattern. Let's isolate one event. Let's say whether you're going to send the ice cream van. Do you know that for certainty there will be rain or not tomorrow? At 60% level, can you say certain? For you to be certain, it has to be 100%. Or for you to be, you know, extremely positive about that there will be no event, it has to be 0%. So in this case, not like 100, not like 0, you have been given a 60-40 scenario. So in such circumstances, under probability theory, we can easily multiply the probability by the outcome and get the expected outcome. That is what we are going to do here. I'm going to assume that we send the ice cream van on this particular day. So if I send my ice cream van, there'll be 60% probability that I will make a negative 5,000 case. Plus, important plus, there's a 40% chance that I'm going to make a profit of 15,000. Take a moment and try to understand what we have done. There's a 60% chance that I'm going to make a negative profit of 5,000. And there's a 40% chance that I'm going to make a positive 15,000. So this is nothing but the expected value that we have calculated for this particular event. On the other hand, I'm going to pick the other van, the noodles van. So for the same event, of having rain 60%, this will be the value. There's a 60% chance that I will make a profit of 1,000 plus there's a 40% chance that I'm going to make a profit of 1,000. So these are the values that you need to calculate for you to get the expected values under these particular two choices for this particular event of rain happening at 60%. If you calculate this, you will come up with a value of 3,000 here and 7,600 here. So it is obvious that you have to send the cup noodles van with a probability of 60% raining. So which van should the company take into this event? The answer shall be the cup noodles van. Justify your answer by we are not certain as to whether there will be rain or not. So in such circumstances, under the probability theory, what we could do is we can multiply the probability by the outcome and compute the expected outcome with the level of probability defined by somebody. And what do we need to do from a company's point of view? Do we want to make a less profit or a higher profit? Obviously, a higher profit. So that's why we have selected the maximum profit outcome of 7,600 coming from the noodles van. So that's the brief explanation that we have to give for this question. Okay. Then the second part. Just take the questions also here. Yeah, look at the second part. If weather forecast changed to 30% chance of rain, which van should the company take to this event? Previously, what was the weather forecast? 60% weather to be gloomy or raining and 40% to be fair. Now it has drastically changed. A 30% chance to rain, 70% to be having fair day kind of a weather. What will merely change in this equation is nothing but now these profit figures, will they change? No. They are for the finite outcome. There is 100%, this will be the value. So only values that is going to change here is nothing but these four. Instead of 60 and 40, what will happen now? The chance of raining will change to 30. So in that case, chance of having fair weather will be changed to 70. Right? Same for the noodle scenario. And accordingly, these two values will be new values. Take a moment and try to calculate. You will come up with a number set like plus 9,000 here and plus 4,300 here. Now the weather forecast being changed, the 60% being changed into 30%, we can say, okay, there is a high chance of having a fair weather, and hence this 15,000 is going to overtake this 12,000 profit in the scenario of noodles having more profits. So eventually ice cream man is going to win now. And the answer will be, if it changed to 30%, which van should the company take to the event? It's the ice cream van. Again, to justify the answer, you can say the same argument, profit maximization. And also you could say the change of probability shall turn the previous decision into the flip side. Why? Because of the expected value being higher in the ice cream in that case compared to the noodles van. Okay. Right. Now, how many marks for that question? 5 complete marks. Look at the next question. 2019 March, same paper, just the adjoining question, part number 4 of question number 6. Yeah. In a group of 100 undergraduates, 60 are male, 40 are male, 65 are studying economics. 16 of the male undergraduates are not studying economics. That's all we are given. We know that epsilon, or the total group, shall be 100, 40 male, that should be 60 females in that case. 65 are studying economics, that means 35 must be not studying economics. And 16 of the male undergraduates are not studying economics also. The questions. The undergraduate selected randomly is female. It's a statement. An undergraduate selected randomly is female. Calculate the probability that she is not studying economics. That's the first question. Second question. Calculate the probability that a randomly selected undergraduate will be female and studying economics. The end part, if you see it carefully, will be studying female and studying economics. Seems to be giving a addition of these two particular events, being female and economics. Okay, we'll discuss that answer. Now, to approach a particular question, there's not, under probability theory especially, there's not one particular way. You could argue that the same way that a teacher is doing could be done in a different way to get the answer. So as long as your method is justifiable, you're perfectly fine. You'll be given full marks as long as you come to the same answer by using a different method. So mostly in my case, I really like to use the tree diagrams, and in some cases, I just use the Venn diagrams. So those are the basic building blocks of the statistics. Rather, they will always give you a visual way to understand yourself, make yourself very comfortable to understand what type of a question being asked in the first place. And you will not miss anything also on the second aspect. So in this case, I will use a small Venn diagram to elaborate the case. The total population is 100. Question has said 40 are male. So from that, I'm going to make a conclusion. Male should be 40 in this particular site, and female should be 60 in that particular site. What is the event that we are focusing here? Whether studying economics or not. So if I focus on this area, now there will be some students studying economics under here. There will be students who are not studying economics also. On female sides also, you can say there will be one portion of students studying economics and not studying. If I draw a line like this, it will make the population into 4 quadrants. But that doesn't really help us to understand whether the complete population of one particular event being happening. That is also a possible way to look into the scenario. But the easiest way is to put up circle here and name it as the particular event that we are focusing, whether we are studying economics or not. Now, in this particular area, I can plot the students who are male and not studying economics. In this small circular area, I can put out the students who are studying economics. So this is one of the easiest way to plot the question into a visual form. Okay. So what else do I have the data here? 65 are studying economics. That means this should be 65. This entire male and female economic students population is 65. One further data is given. 16 of the male undergraduates are not studying economics. That means I can plot them here. 16 who are not studying economics. That means now I can fill the rest of the missing areas. I need to understand these 3 values. If 16 is here, that means you should have 24 students who are studying economics, being male. And if 24 is here, the total is 65. That means we should have 41 here who are studying economics. And if 41 is the area here, that means 60 minus 41, you should have a value of 19 here. So this way, you can put up the entire statement into a visual form. Let's try to answer the questions. An undergraduate selected randomly is female. Calculate the probability that she is not studying economics. Now, look at the statement. An undergraduate selected randomly is female. Now, they have selected one person. And this entire side, you can forget for a moment. We are jumping into this particular quadrant. Is female statement denotes my population into this 60 area. Okay. An undergraduate selected randomly is female, 60. Calculate the probability that she is not studying economics. It's simple as you can take this 19 out of 60 for the answer. But if you really want to, look for the theory, what is being tested here is conditional probability. I will name this event as not doing economics as NE. In that case, what is being asked here is that probability not doing economics given female. And you can take your time and denote this to come to conclusion. Not doing economics and female, the number is 19. Probability female, 60 out of 100. That means 60. This 19 is actually 19 divided by 100. This 60 is also 60 divided by 100. So eventually you don't have to write hundreds here. And you see, say 19 divided by 100 as the answer. Look at the second one. Calculate the probability that a randomly selected undergraduate will be female and studying economics. Calculate the probability that a randomly selected undergraduate. Now, has it selected any undergraduate for being economics or being female or being male? No. We are still at the whole Epsilon level, 100. Calculate the probability that a randomly selected undergraduate will be female and studying economics. That means you have to, from this 100, go to the female quadrant and get the number of chaps who are doing economics. That means easily you can use a diagram and argue. That will be 41 divided by 100. That's the answer. Okay. So this is also one easiest approaches to reach for these questions. You could say, you can use a tree diagram also. You can say male and female, doing economics, not doing economics, doing economics, not doing economics. You can get the same set of arguments for this case. But this is also another easy way to give it a try. Okay. Next question. With that, we have completed 2019 March paper also. We'll look into 2019 September paper. The very first question of your compulsory. Read the question. In a survey of a bank, 45% of the employees had decrease in economics. That means 55% of the students, the employees must be not having a degree in economics. Okay. And 60% had degrees in statistics. 40% must be not having stat degrees. The probability that an employee chosen at random had a degree in economics or a degree in statistics is. Now, look at the two incidents carefully. "45% of the employees are having a degree in economics. That means 55% not having economics. 60% having stat. That means 40 does not have stat. What is asked is to get the probability that an employee chosen at randomly had a degree in economics or a degree in statistics. You can use all three different methods. You can argue using the probability set theory, you can argue using a tree diagram or a Venn diagram. So just for the completion's sake, this question I'll try it using a tree diagram. Now randomly chosen employee, try to a randomly chosen employee, I'm going to state the first argument or the first event. That is, having a degree in economics. E stands for economics. NE is going to stand for not having economics in this case. Okay. Now, in the question paper, now in this particular instance, this is a MCQ. That's okay. You can just plot it just for 2 marks. But if it is in a elaborative questions, if at all you use some of these notations, be careful to just put up a key and say what E stands for, what NE stands for. Also, okay. Take that best practice always. So 45% chaps have economics. That means this has to be 55%. And the second event I'm going to write, this is for the economics, and this particular event for having statistics or not. So 60% had degrees in statistics. That means 60% have statistics, NS for not statistics. So 40% chaps will not have statistics. Similarly, whether you have economics or not, that doesn't really going to impact whether you are going to have a stat degree or not. Yeah? Because if it is the case, the question has to tell you that whether an economic degree having employee will have some sort of a relationship with the statistics degree. Question doesn't really say so, so they seems to be independent different events. So you can plot them and see what is being focused and asked. Question says, had a degree in economics or a degree in statistics. That means basically all what you have to omit is this particular part. This line doesn't have a degree in economics or statistics. One way to easily would be to take the multiplication of these two events, remove from 100. Or if you really want to amalgamate all these, you can add up these three particular events and also get the same answer. Why? Because at each of these stages, the total probability will add up to 1. So 55% into 40% shall be somewhere around 22%. So that means the answer shall be 100 minus 22. 78%. We have the answer of A being 0.78 as the correct answer. Okay, so in that paper, we have some more questions on coefficient of variation. We have covered arithmetic mean. We have covered. Moving on, we will find a doable question in question number 5. It's a complete 20-mark question where you can spend maybe around good 20 to 30 minutes and score it perfectly. Let's read the question together. A dairy production company produces set yogurt cups whose weight are normally distributed. That's important, normally distributed with a mean of 80 grams and a standard deviation of 1.5 grams. This company plans to buy a new machinery to produce fruit yogurt cups. The specification, so that means we have now two yogurt lines. Okay, don't forget set yogurt line and the fruit yogurt line. The specification for the new machinery state that the weights of fruit yogurt cups are also normally distributed with 11.55% of fruit yogurt cups with a weight over 82 grams and 5.89% weighting under 78 grams. Okay. Look at the questions that they're asking. What is the probability that a set yogurt cup chosen at random weighing less than 75 grams? Second question is asking, it seems to be asking for a monthly profit for a particular shop that could be earned by selling some yogurt cups. So it seems to be again set yogurt cups. Third question is asking, calculate the mean and the standard deviation of the weights of the fruit yogurt cups to be manufactured with the new machinery. There only the new machine comes into play. Fourth one is asking the coefficient of variation of the two machines and asking us to take a conclusion on which produce set yogurt and fruit yogurt cups. What can you tell about these two machinery from your answer? That means to find whether a particular machine is better than the other machine. Okay. Right. Let's look at the first question. What is the probability that a set yogurt cup chosen at random weighing less than 75.5 grams? We'll focus on the data on the set yogurt machine first. Now, this seems to be a question coming from the standard normal distribution because the question itself starts with a assumption saying which are normally distributed. So, in such circumstance, one of the easiest ways to look into the question is to plot a small normal curve like this and try to plot the values that you have been asked to. The set yogurt has a normally distributed with a mean of 80 grams and a standard deviation of 1.5 grams. Okay, mean I can plot here as 80 and standard deviation as 1.5 grams or 9 grams. Okay, that's all given on the set yogurt machine. The question asks, what is the probability that a set yogurt cup chosen at random weighing less than 75.5 grams? So 75.5 should come here, less than your mean. When you been asked the probability, we have always come to the conclusion that this area under the curve should give the total probability of that particular event being lying in this particular area. So we can use the same Z computation if you could recall x minus x bar divided by the standard deviation is the equation that we're going to use. So by applying the individual values in this circumstance, you have 75.5 here minus 80 is the mean for the set yogurt machine. I'll write as set here so that we'll avoid it. And the standard deviation is 1.5. So this will give me an Z value of negative 3. 75.5 negative 4.5 divided by 1.5 is negative 3. So now what we have to do is that we have to use the Z tables given in the table set in the back side of your question paper and take the Z equals to negative 3.0 value. That will be 0.00 from tables. You can say this is 0.00. 0, 0, 1, 3, 5. Right. That means this particular area is, this is the absolute form. If I take it for the percentage term, this is 0.135% of data should lie in this particular area. That's the answer. That's the answer being expected. What is the probability that a set yogurt cup having a weight less than 75.5? This is the answer. 0.135% is the answer. Okay. Look at the second part. All set yogurt cups weighing less than 75.50. That means this particular setup are not issued to the market. Right. So they can't go to the market. Why? Because they seem to be having a lesser weight compared with the stated average. They're not issued to the market. Rather, they are given to the company's welfare shop free of charge. Welfare shop sells those yogurt cups at 20 rupees per cup. If company produces 500,000 set yogurt cups per month and welfare shop sells only 96% of those yogurt cups, calculate the monthly profit the welfare shop could earn by selling these cups. Simple multiplication. How many yogurt cups that the company is producing in this month? It is given as 500,000 set yogurt cups. 500,000 set yogurt cups. So from this total production, we have previously calculated that 0.135% of the cups shall be taken into the welfare. That means this multiplied by 0.135 should give me the number of cups that shall be given to the welfare shop free of charge. And from those cups, now this is a monthly target, monthly figure. Okay? Now from those cups, the welfare company only sells 96%. That means 4% they will be not able to sell it. And what will happen? Yogurt will get expired. So they'll have to throw it away. Are they making any losses? No. Why? Because they have been given free of charge. And the final missing piece is the price at 20 rupees per cup. That means this whole multiplication, 500,000 production, 0.135% scrap for the wastage, go to welfare shop. They're selling 96%. Price per 1 cup shall be 20 rupees. This multiplication should give me the total profit that the welfare shop is going to make in a month. We will come up with an answer close to 12,960. Now bear in mind, if you get a marginally different answer for this 0.135, it will come here and it can change this figure. Don't worry, as long as your calculations are clear for the examiner, you will be allocated marks. Okay. Now only the second machine comes into play. Look at the third question. Calculate the mean and the standard deviation or the weights of the fruit yogurt cups to be manufactured with the new machinery. What is that? And they have been given the mean and the standard deviation? It appears not. We read again the question, the last part. The weights of the fruit yogurt cups are normally distributed with 11.5% fruit yogurt cups weighing over 82. Okay. And 5.89 something weighing under 78. Okay. But still we don't know the mean and the standard deviation. So what shall we do? And that is the exact two indicators that the examiner is asking. Okay. So don't worry, we will forget this yogurt machine, now it's gone. We will try to plot whatever we know in the same standard normal curve of calculation form and see whether we can find some sort of a relationship for these two particular values. Okay. This is the fruit machine that is about to come.
Do we know the standard deviation or the mean? No. So I'll put m here and standard deviation form. I will just put these two numbers as it is. These we don't know. But the question says, okay, 11.55% of fruit yogurt cups weighing over 82 grams. Okay, so that means 82. This particular area is given as 11.55%. All right. On the other side also, other tail also, they're given a similar data. 5.89% are weighing under 78 grams. This particular area is also given as 5.89%. What we can do is, we can use the same Z equation and see whether we can get two simultaneous equations for these two values of m and sd to be inserted and try to solve. Okay. For the first one, 82, I will write the Z form and see whether I can find any such relationship. If I want to get this Z value here, what happens is, I have to write Z should be equal to 82 minus m divided by the standard deviation. For this side also, if I want to write, I have to write Z, here I write Z at 82, Z at 78. That means 78 minus m, don't forget the mark sign here, 78 minus m divided by the standard deviation should give me the particular Z value. What do I know at this point is that this Z value should correspond to this 11.55% here and this 5.89% here. Okay. Let's take this for the first time. So for this 5.89% to be lying on, we switch back to our tables, and from the negative side, when you scroll down carefully and look for 0.0589 to be in the particular Z range, you will find approximately negative 1.57%. Sorry, not percent, negative 1.57 from the tables, negative 1.57 from the tables to have an approximate value of 0.5821. That means more or less close to 5.8. Okay, so that means this particular Z value should be negative 1.5. What about this one? Can we directly take 11.55 here? Don't forget the theory. We have said Z table will come from the left hand side to the right hand side. That means we have to first take 100% minus 11.55% for this to be considered. Isn't that so? We take 11.55 from this end, that means eventually we are only taking this 11.55% from negative infinity to 11.5. That's not the case. We have to take 100 minus 11.55, and that particular value has to be looked from the table. That means we have to look for 88.45% from the tables. So we'll scroll back again to our tables, go for the positive side this time, and look for 0.8845 for a nearest value for us to get this particular Z value at Z82. Okay. If you look carefully, you will find approximately plus 1.2. To be the Z value here. I hope those two are very clear. From negative side, easily you can take, but for this one, you have to take 100 minus 11.5. So what we have done here, forget these Z numbers. Now we have two equations that could be denoted below. I'm going to write it for clarity. 82 minus m should be equal to 1.2 times st. This is one equation. From this, you can denote 78 minus m should be equal to negative 1.57 times st. That should be equation 2. We have two equations and two unknowns, and easily you can resolve this. Sometimes you can use the calculators also, but since if it is a quadrant or some kind of upper power equation, easily you could use the calculator. But just by taking off 1 minus 2 or 2 minus 1, we'll take off this m, and you will be left with SD, and you can calculate SD for 1 and apply that SD for one of these two equations. Take this to other side, take 1 m for this side, where you will calculate m. Okay, we don't have to spend time there. But give the answer, m should be equal to 80.26. What is m? That is the meaning of this particular new fruit yogurt machine, 80.26 amps. Once you apply that m for one of these two equations, you can get the standard deviation value also. Yeah, standard deviation will be 1.44 approximately by applying this m to any of these two equations. So these are the answers for part number 3. Little bit of calculation, but all, if you look at the glimpse of it, what we have done is, most of the cases you'll be given the mean and the standard deviation, and we'll ask you to compute one of these two values. But what this question has done is that given two instances, given two particular z values to be computed using the area under the curve. I08. Now this less than scenario, easily you can directly take from the table for Z78. That means 78 minus mean divided by standard deviation should be equal to negative 1.57. That is the area under the curve for 5.89%. But don't get carried away. For this particular instance, you have to first assume that, okay, 11.55 seems to be the higher side. That means you will take the area for 88.45% to be your Z value. For that particular area of 88.45, you will be left with a Z value of plus 1.20. Then when you look back, forget these two Z values. That means you're left with two equations where two unknown values are there. 82 minus m is equal to 1.2 times standard deviation. 78 minus m should be equal to negative 1.57 times into standard deviation. So two equations you can easily resolve and get the answers for m and st. So eventually you will undo this abbreviation and express your answer as the fruit yogurt machine will have a mean of 80.26 grams and a standard deviation of 1.44 grams. That should be sufficient. Last part, coming from one of our previous theories on coefficient of variations. Calculate the coefficient of variations of two machines. Coefficient of variation is nothing but standard deviation divided by the mean. Now, do we know the standard deviation and mean for these two machines? We do. Shall we calculate it first and see? So for the fruit yogurt machine, SD divided by mean should give you a value of uh, standard deviation we calculated previously 1.44 divided by 80.26, which should be equal to 0.0180. For the set yogurt machine, sorry about that. So for the set yogurt machine, let me just try somewhere else. Again, standard deviation divided by mean. Now those two values are given in the question itself previously. This is 1.5 divided by 80. That should give you a value of approximately 0.01875. Look at how close these values. 0.0180 to 0.01875. Up until these 2 points, values are same. Which produce, yeah, calculate the coefficient of variation of two machines. So these should be the answers for those two values. What can you tell about these two machines from your answer? And that's the elaboration part or the analysis part. You can say, now this is less than this particular value. So you could denote that fruit yogurt will have the more accurate and less dispersed value. The dispersed nature for the fruit yogurt compared to the dispersed nature of the set yogurt, we look at it. This is much more concentrated or centralized compared to the set yogurt machine. That's the conclusion that you can make from calculating the coefficient of variation. That should give you the complete marks for this question on question number 5. Look at how beautiful the question could be elaborated up until the third part. You've been asked to calculate standard normal distribution type of questions. And all of a sudden, the moment you have the standard deviation and mean, examiner can test your knowledge on coefficient of variation. That's the final conclusion that they have to make. I mean, look at how the numbers are very close by. If you miss these calculations by a margin, your answer may be turning into flip side. So always at the final exam, maybe have a good practice to not to round up your answer till you go to the final mark of a particular question, final point of a particular question. Okay. Right. With that, I think this paper is over. Let's see. 2018. No, there's one more question. Yeah. Now that's a complete 20-mark question where you can score as long as you're comfortable with the probability theory. Look at this part. Question number 6, subpart number 4. A company manufactures exercise books on 2 production lines, line 1 and line 2. Line 1 produces 60% of the total production. 100 books from each line were tested for quality control purpose, and the results are as follows. And they have given the table. Okay, line 1, if you take 100, now this nicely tallies up to 100 books itself. 88 are accepted and 12 are rejected. From line 2, 94 are accepted and 6 are rejected. So on the glimpse of it, line 2 seems to be more accurate compared to line 1. However, we don't have to forget that line 1 eventually produces more than line 2. 60% of the books are coming from line 1. For the questions, calculate the probability that a randomly selected book will have been manufactured on line 1 and having rejected quality. Read it again and see. Calculate the probability that a randomly selected book will have been manufactured on line 1 and have been rejected for quality.
quality. Second part, calculate the probability that a randomly selected book will have been manufactured with the accepted quality. So give it a shot and see. I can use a tree diagram here and see how I can plot these two particular events of whether we are coming from line 1 and line 2, or on the other hand side whether they are of good quality and bad quality. Well, first I have a little trouble with the board. I hope you can see this side. Yeah. So first I will denote from whether a particular item is coming from line 1 or line 2. Line 1 should be 60% here, 40% here. As it given in the question, yes. Line 1 produces 60%, line 2 should be then 40%. So these numbers I can again break into, I'll say this is good quality, yeah, good quality, bad quality, good quality, bad quality. From line 1, how many items are of good quality? 88. How many items are of bad quality? 12. From line 2, 94 of good quality and 6 of bad quality. Calculate the probability. Right. Calculate the probability that a randomly selected book will have been manufactured on line 1 and having rejected the quality. So first, that means this has to be manufactured from line 1. We have to go from this branch. Right? Having rejected the quality, this particular branch. This is the probability that they are asking. The probability, students, when you really drill down, all what is left for you is to map whether you have been asked for a particular event to be focused, or you have been asked for a particular conditionality to be fulfilled, and how you are going to define that. That's all. As long as you define that, okay, this is coming from line 1 and that is rejected, you can narrow it down to this particular line. If the English is marginally different, let's say conditionality is being given, it has come from line 1, or rather it has been randomly selected, then that means you have to go for a different branch. That's how you define this particular data. So this is pretty easy. You have 60% for first come line 1 and 12% or 12 divided by 100 or 0.12% for the quality to be rejected. That means the answer shall be 0.072 as for the first part. And the second part, calculate the probability that a randomly selected book will have been manufactured with the accepted quality. Alright, that means these two branches, either it can come from line A or line B, line 1 and 2, sorry, and it could go for accepted. That means this plus this. Easy. 0.6 multiplied by 0.88 plus 0.4 multiplied by 0.94. This should give you a value of 90.4% to have the accepted quality. 5 marks. Yeah, that's on 2018 November paper. Sorry, September paper. Now let's look into the 2018 March paper. The very first question, starts with a probability like in the previous paper also. In a bank, 55% of the employees are male and 75% are economic graduates. The probability that an employee chosen at random is either female or an economic graduate is. You get the question? 50% of the employees are male, 75% are economic graduates. They want us to identify the probability that an employee chosen at random is either female or an economics graduate. Without drawing anything, you can merely argue for this question. Let's look into this way. Either female or economic graduate. That means this is an addition of probability. Now, what is the probability a random selection of female is going to be? That is 0.45%. Sorry, 0.45 or 45%. Okay. Or an economic graduates. So from those 45% and from these 55% of males and females, 75% will be economic graduates. Now, do you want to go and choose economic graduates and non-economic graduates in the female region? You don't have to. Why? Because the question is asking whether female or economic graduate. That means being female is enough from that branch on the decision tree. So 45% plus a 75% on the 55% of the male population should give you the answer. Isn't that so? Just try to calculate it. That means 0.55 into 0.75 should give me approximately 41.25% as the male economic graduates. Can we take male non-economic graduates? We can't. Why? It should be either female or an economic graduate. That means that answer of 0.4125 plus 0.45 should be the answer for this question. That means 0.45 plus that particular 0.4125 is giving me an answer of 0.8625. Do we have an answer? Yes, we do. Answer A should be the correct answer for that question. Okay. See, sometimes you don't have to really draw the tree itself. Rather, you can argue with common argument grounds. But it's always best to draw the diagram, because sometimes you may tend to miss certain things if you try to go with non-visual means. Let's look at the subpart number 3. Consider the following statements on the characteristics of a normal distribution. Which of the following is correct from the above statements? Okay. They're asking for the correct statements. Let's see. It is a perfectly symmetrical bell-shaped curve. It's correct. B. The mean, mode, and the median pass through the peak of the curve. That is also correct. That is one of the theories that we discussed. As long as the perfect bell-shaped curve comes into play, we don't see mean, median, and mode taking different places. Rather, it will intersect or it will cross at the same point. So statement B is also seems to be correct. Statement C, the tails of the distribution touch the horizontal axis at 2.5 standard deviations from the mean. Now that's the wrong statement here, because we have learned the tail of the distribution will never touch the horizontal axis, and it will go to plus infinity and negative infinity for any standard normal distribution. That's why even in the previous confidence interval discussion also, we have never discussed at 100% confidence interval. We can't say. We will never know the 100% confidence interval for probability questions unless being stated at the question itself. Look at the statement D. Approximately 68% of the observations lie between plus and minus 1 standard deviation from the mean. That's the rule that we discussed under 65, 95, and 99.7 rule. That's also a correct statement. So apparently, we can get answer B as a correct answer, which says only A, B, and D are true. 2-mark compulsory question. There's another subpart which I have elaborated from elective question number 2, subpart number 4. Look at that question. If you check that with the previous memory, you may find that it's a similar type that is being tested on a previous time also. Isn't that so? Assuming that now forget about the part 1, 2, and 3 of this question that comes from the probability theory. Rather, only focus on question number 4, and we will take some data from the question body and see whether we can come up with an answer for this. Okay. What the question is saying, following table is showing a portfolio, some average returns of each asset class. Average return of the portfolio is forecasted at 12%. Sorry. I hope you can see. I'm sorry. So the average return of this particular portfolio would be forecast at 12%. And the standard deviation of 10%. This is standard deviation equals to 10%. Question says, assuming that a normal distribution describes the portfolio return in 2018. Now, I assume that I wrote it already. Estimate the probability that the total portfolio return will exceed 22%. That means we have a 22% here. We need this particular probability to get the answer. We will calculate the Z value and see. Z should be equal to, at that point, should be equal to 22 minus 12 divided by the standard deviation of 10. That should be 10 here divided by 10. This is 1. Is it equal to 1? From the tables, you can get a value of 0.841334. But does this answer that we are looking for? This accounts for this entirety of negative infinity to up until this point. Rather, we want the more than that scenario. That means 1 minus 0.84134 should give us the answer of 0.1587 or 15.87% probability is there for this particular portfolio in 2018 for the return to exceed 22%. That should be the correct answer for this question. Yep. We have 2 more questions in the same paper, but probably we can pick the question number 5, which is a very good question, and finish up our discussion. And don't forget the fact that we are missing certain questions. All these questions in the past papers are very interesting. Rather, we will, if at all we are missing any question, don't worry, we have earmarked them. We have plenty of times after the theory discussions. Don't forget the fact that we are only having just 2 hours for a theory area to be completely discussed and practice some of the questions, which is not really sufficient in certain subject areas which has a higher amount of theory to be discussed. So don't worry. Those questions that is been left out in 2017, 16 and 14 papers, we will somehow try to cover it up with revision sessions and the mock examinations also. Okay. Read this question. A company, this is the question, 2018 March, question number 5. The company produces chocolate packets with nominal weight of 400 grams. There are 35 chocolate pieces in each packet. That seems to be distracting information. Let's see whether do I really need that. During the production process, weight of each chocolate piece varies, and on average, the weight of each individual chocolate piece is 12 grams. Now, that's the important point to highlight. Weight of each individual chocolate piece is 12 grams. That's given. Oh, sure. Hence, the average weight of a packet is 420 grams. How do they come up with this value? That means 35 pieces into 12 should give me 420, right? With a standard deviation of 10 grams. Now, whether they are discussing those for the individual piece or the packet, as for the packet, that's the part you may miss in this question. Company produces 100,000 packets in a month, and the production cost for each chocolate piece is 6.5 rupees. So obviously, those will be for the uh, part number 2 and 3. We will try to answer part 1 first. Okay. Right. Calculate the probability that a chocolate packet will be below the nominal weight of 400 grams. Now, the only mess up that this question can come bring up to your discussion is that whether you're going to focus on the packets or the individual chocolate pieces. The pieces should never be looked into this case. Why? Because if you look at the next couple of questions, you've been always asked on the packet, and the standard deviation and the weight and the mean of the packet is being given. If at all they're asking for maybe one or two further questions on the individual weight of a chocolate piece, then we will focus on the piece. Rather, uh, now let's focus on the packet and the standard deviation and the mean of the packet itself. Okay. Okay. Now they're saying that it's normally distributed. So the first thing that I'm going to do is I will draw this small notation of a normal distribution and try to be able to. What's the average weight of a packet given in the fourth line? That is 420 grams. 420. Standard deviation is 10. We have been asked to calculate the probability that a chocolate packet will be below the nominal weight of 400 grams. Company is promising that the average of this packet will be 400. But the study has shown that it is not the case. It is slightly higher, 420 grams. Question is asking to calculate the probability that even lesser value will be taking on actual grounds. Calculate the Z value here. Z will be 400 minus 420 divided by 10. 400 minus 420 divided by 10. This is negative 2, isn't that so? Negative 20 here divided by 10 should be negative 2. So for z of negative 2, you can use your tables and get this value as 0.02275 or 2.3% approximately will be the area under the curve from the left hand side up until 400 range. So how do you elaborate this answer? You can say there is a 2.3% chance that the chocolate packet will be below the nominal weight of 400 grams. Okay. Second part asks, any customer who receives a chocolate packet with a weight less than 100 grams can obtain a cash return of 200 rupees from the company.
for each such underweight packet. Right. That means if somebody has received a packet from this region, they can ask for a cash return. Past records of the company shows only 30% of the customers who receive the underweighted packets claims this cash return. That means 70% don't really bother. Only 30% of chaps will come to the company. Calculate the expected monthly cost of cash return. Now that's the last last line of this question. It says company produces 100,000 packets, isn't it? So that means what we are looking at is 100,000 packets multiplied by 2.3% to be the risky range of having less than 400 grams. And from those chaps, 30% will come to you. So this again multiplied by 30%. And per packet, if somebody comes, we are paying them. But how many? 200 rupees. This is the answer. 100,000 packets, 2.3% on the lesser range. 30% of them comes to you. You will pay them 200 rupees. Okay. So the expected cost to the company shall be 138,000 for nearest. Let's spend a couple of more minutes and finish off this question. If the company puts 36 chocolate pieces in each packet, now company is adding one more extra chocolate piece into the packet. What is the revised average weight of the packet? It's a very simple question. Don't get very confused. Now, what's the weight of individual chocolate piece? That is given in the third statement saying 12 grams. Now, already we have 35 pieces in this chocolate packet, which has 420 grams in it. How do they come up with 35 into 12? You add one more, that means 36 into 12, that should be 432 is the answer for that part. What is the revised average weight of a packet? That should be 432. If the revised standard deviation of the weights of a packet is 8.5 grams, now by adding that, they have the summation or the combination of those 36 packets has given a revised standard deviation of 8.5 grams. SD has changed from 10 grams to 8.5. Calculate the probability that a packet of 36 chocolate pieces will be below the nominal weight of 400 grams. Now for that, what do we have to do is again, I've used the same this thing here. This has changed to 8.5. Now average, now it is 432. Our earmarked Z value is same. We will again calculate the Z value. This will be 432 minus 400, sorry. This is 400 minus 432 divided by not 10 here, 8.5 should give you a Z value of negative 3.76. Now this is a very interesting point to look into. If you go to your tables and look for negative 3.76, now this is almost close to negative 4. We discussed previously, your range can be negative 4 to positive 4 for us to look for sensible probabilities. It can go more than plus 5, plus 6, negative 7, negative 8 can go. But eventually, if you look at to maybe 3 or 4 decimal places, your probability will be 0. Similarly, when you look at negative 3.76, your Z value shall be 0.00008. That means 4 zeros and an 8 will eventually give you, if you round this up to maybe 2 decimal places, you will be left with 0.00% probability, or you could, eventually it is almost equal to 0%. So the answer in that case will be calculate the probability that a packet of 36 chocolate pieces will be below the nominal weight will be nearly 0%. That would be a perfect answer, nearly 0%. Last part is asking, would it be profitable for the company to put up 36 chocolate pieces in each packet to reduce the monthly cost of cash returns? Now, what they're trying to, earlier we calculated that the company is spending 138,000 for the cash returns. Why? Because 2.3% of the production goes below the standard 400 grams. Now what they have done? They have added one more packet. With that, now they are claiming there is absolutely 0% for the packets to have a value of less than 400. It's a good thing, right? What they want to compare is that now there's an additional cost. How does that cost come? They input one more additional piece per packet, right? So that means they're producing 100,000 packets in a month. Last line has given us in a month, and the production cost of each chocolate piece is rupees 6.5. That means for this production to happen, and in this production month, we have assumed that 138,000 is the cost for the returns. So for this 100,000 packets, that means you are inserting one more chocolate piece per packet at a cost of 6.5 rupees. That means you have 100,000 multiplied by 6.5, that is close to 650,000 rupees. This is, sorry, the word is not very clear today. Should be 650,000 rupees versus 138,000, which is absolutely not worth. Why? Because your cost for this additional one bar or one piece to be put up for the packet is much higher than the returns cost. That's the answer for that last part of the question number 5, subpart number 4. With that, we can conclude today's session in the interest of time. But let me just show you the other questions that we wanted to discuss with you. So for you to give it a shot when you have time by using the suggested answers in the paper itself. We discussed up until 2018 March today, and then we have 2018 March subpart number 4 for a 5 mark. Similar to one of the questions that we did previously, we have 2 lines and accepted and rejected and asking for multiple combinations on this output. 2017 September paper also, there are a couple of questions. Subpart number 3 of question number 1 is an MCQ. Subpart number 4 is also an MCQ. Subpart 9 is also an MCQ you can attempt. And then we have from the portfolio theory related the question. Now we have 2 parts that is given for 5 marks each. If you look at the nature of the question, is the exact same thing that we practiced previously. We have a normal distribution and estimate the probability exceeding a particular value or in between particular value. 2 questions being given for 2 5 marks. Question number 6, I think subpart number 4 here. It's also asking for a standard normal distribution estimation. That's up until 2017 September. There are a couple of more papers down the line. We will pick up those questions as we can find some time. Okay. With that, we can conclude today's session, and hope you had a good session and you understood some theories into probability and standard normal distribution. Now don't forget, if you can practice the probability, you can comfortably get maybe 20 to 25 marks from the question paper, all around the question paper. So maybe if you're lucky, you may find at least 30 to 35 marks, and that means only another few marks to come to your pass mark, provided you do the question successfully at the exam. Okay. So with that, I reiterate, we are closing the first 50% of the session. We'll be starting the next session with a fresh opening on the regression, simple regression
multiple regression time series and connected definitions. Okay. Have a good evening.